So, why is the consonant cluster page included in the scan?
Well, we want to have a page where we can analyze how sequences of sounds, such as SP or BR, come together. The sounds that arise together in which we document tend to be two consonants side by side, consonants that are separated by vowels, or vowels that are separated by consonants. This is where the scan starts to show us how sequences or clusters are truly nonlinear.
Right, nonlinear. I sometimes wonder how that works when you have many segments to deal with, or clusters. I see on the page there it says neighbors, but it doesn't necessarily mean next door neighbors, right?
That's right, Dave. The neighbors we're talking about are simply any segment that is having an effect on another distant or not so distant neighbor. That's nonlinearity.
Great. Well, now what I need to know is, how do I use this page?
Of course, let's look. On this blank scan, we can see that there are all of the possible clusters or sequences that one could make when combining two consonants. They're on the left-hand column there. You can list or circle the ones that the client has and include any transformational patterns on this part of the page. For example, the first one says with W, J, or nasal, right here. If the child has, for example, a BW or an MY sound occurring together, we could circle those. Or if a sequence of TW transformed itself into a single T, you would list that as a pattern, word initially, or word medially, wherever it occurred. With these phonological patterns, we look mostly at two consonants together, but you can see that if your purposes lend itself to it, you can include the three consonant clusters, which mostly tend to occur at ends of words. So this is the line where you would insert those.
I see. So you have all of your options plotted out and you're filling in the blanks. That's great. I can see how it works, sort of, but I still don't understand what I'm plotting here.
Okay, let's take a look at Craig's completed scan. We see that most of the things that have been included on the chart are a need. I know this because it's the script in red. These are segments that he has not yet established or that he has changed in some way. In the top section, we plot this change to see in what word position the changes occur. We can also plot segments that are strengths, ones where negative constraints have not resulted in changes to the targets. You can then use these strengths, as well as the old phonological patterns, to support treatment goals later. Basically, you take any old phonological pattern and place it in new contexts. You can do with this with the needs as well.
So, in the with W, J, or nasal category in the first row, we see that word medially and across syllables, Craig turns an engma and G sequence into J. Cool. That makes sense to me, I think. So here in this other example where it shows the sequence R followed by PL, it's indicating that this R and the following sequence PL are reduced to only P, here. I notice that we don't include the word where this change happens.
That's right. In this section, we do not need to. We could, but there's not really a lot of room. So that's where the next portion of the page comes in. My favorite, mismatch patterns. Do you remember all of those linguistic processes you learned about in undergrad? This is where you can plot these sequences and segment repairs to constraints that the speaker has. The changes or constraints include assimilation, dissimilation, metathesis or flop, epenthesis, coalescence, and deletions, if there happen to be any. These constraints are a response to a negative or markedness constraint on the sequences. This means that when a sequence is changed, it has avoided a phonological pattern that is, for the time being, not acceptable.
I'm beginning to get it. So in that example where the R followed by PL becomes P in the word airplane, the PL doesn't allow the occurrence of L. I noticed that airplane is in the assimilation section of the mismatched patterns. Why is it there? There must be a repair pattern in the output. Am I right?
Well, in the section above, we noted that the R-PL cluster made a change, so we documented it up above. However, in the middle section, we are noting the constraints that are used to avoid markedness on the sequence. In the word airplane, right here, It shows us that the child system has a constraint against vowel initial words. A glottal stop is not enough to start a word. But what to do with the word that starts with an eh sound? Where is the consonant going to come from? Well, there's a P coming up in the word. So why not reduplicate or assimilate all of those P features? The reduplication or assimilation pattern is thus regressive. The labial stop P triggers the labial voiced stop B. And why B and not P, you might ask? Well, we know already from page 4 that word initial voiceless stops are less well established than voiced. So the voiced labial B is more in keeping with the constraint against word initial voiceless stops. The repaired pattern and resulting word is Bepe. You will simply have to determine for yourself what phonological patterns are going on in your data set. You can do this word by word after you have your data when you see changes. This is where you really need a good eye to pick out those phonological processes and from what direction or segment they are coming from.
Okay, back to the scan. So I can go through and I can figure it out. That may take me some time, but I'm willing to tough it out if it means that I can create some good goals, and then I can figure out all of his strengths and needs. Now back to the assimilation and such. It looks like it's important to know the features, right?
Yes, this is another place where features are used and needed to be referenced. I would suggest having a chart to compare the features of individual phonemes. Or you can look at page 6. In page 6, all of the features are listed on the left-hand column. If you were to go down to P and B in place of articulation, you would see quickly that they have a similarity. They're both labial.
Oh, I see where this is going. Place features are used in this last section of page 5. L stands for labial, having to do with the lips. C stands for coronal, or having to do with the blade or tip of the tongue. And D stands for dorsal, as in the body.
You got it, Dave. Way to remember those acronyms. This last section is where we find out how the place features of each phonological unit, or the sequence, is being affected by the place feature of another phonological unit or sequence. There can be manner or laryngeal sequence issues as well, but place sequence patterns are more common. This section is where we plot the place feature constraints. There will be constraints that do not allow certain place features to arise adjacently or side by side.
That is, Megan, any neighbor near or not so near.
That's right. This is what adjacency is also referring to. You're catching on fast, my friend.
It's not so bad. So let me try to explain this one out. In the labial to coronal example, where there is a need for the word fishing, the constraint is that a labial and coronal cannot exist adjacently, the F being labial and the sh being coronal. So what he cannot do is labial to coronal. But what can he do to fix the problem? What strengths does he have regarding sequences? Well, if we look at airplane, we notice he could do labial to labial. Not surprising here that we also have labial to labial, a same place sequence with a feature he's good at.
Marvelous! There is one other point to make in terms of the sequences on this page. We saw above in the first section that glottal stops and the glide yeah are occurring in medial position of words. Perhaps this is an avoidance of oral place sequences?
I didn't know we could hop around like that. Good inferencing. Okay, page 5 of the scan. You're totally doable. What's next? Oh, wait, I can see it now. Those features we were using, they must have a better breakdown. I mean, it's not like I know the whole story about what happened with the word fish just by looking at the last section of the page. That was only identifying adjacent phonological mismatches. What about the nitty-gritty?
Moving right along in your scan knowledge, I see. So, let's take a look at page 6. This is optional, really, but when you're learning the scan, it's a good idea to practice this page so you can really learn the features. Once they're automatic, page 5 gets much easier. Now, the key here is to follow directions from the top of the page. Read carefully, and all should be well. The singleton substitution page states that you are to describe the substitutions that concern the features on the left of the row.
Substitutions. A change of one feature into another. I understand that. I could probably go about this part just fine. Where's the catch?
There is none. This is as simple as it gets. One word of warning, though, you might be tempted to take your phoneme, which is making a change, and place it in every cell where you find that phoneme occurring, along the left-hand columns. To get the benefit from this page, however, you need only put the segment in the cells where it is showing a true feature change.
That's a good tip. So when I look at Craig's completed scan, I see that the phoneme F is making some changes. The first one being that of continuancy under the manner features. F becomes P. The manner is changing from a continuant to a stop. Here in the left-hand column under place features, though, there's also an F. We wouldn't include that change here because F and P actually have the same place of articulation, at the lips.
Dave, you make my heart proud. Soon you'll be teaching others how to do the scan. Now, all you have to do is document those singleton substitution in the proper word positions. Either word initially, here, medially, in the middle, or finally, at the end. This page is pretty transparent in the way it sets itself up, and by the end, you'll have all of the person's substitutions, or lack of substitutions, documented by word position. At the bottom of the page, you can document the strengths and needs of the client and what features are being used as defaults.
So it looks like Craig tends to make a continue and a stop, just like in the example that I talked about with F and P. So would that be considered a default?
Absolutely. We could put it under manner defaults that minus continuant is a default.
So on page 6, can we clarify what strengths are? It isn't readily apparent to me. I get that we're identifying changes and substitutions, but it's less obvious to me what Craig is actually doing well.
Well, Dave, you're right that we are identifying substitutions and changes, but it is important to note that we can actually identify strengths in a roundabout way by looking at the changes that are occurring or not occurring. For example, we see here that Craig is substituting plosives such as P for a B in word initial position. Although this is a substitution, it actually becomes clear that stops are a strength for Craig.
Oh, okay, that totally makes sense. Within what we would normally think of as weaknesses, we can still identify things that are going well. Like when Craig defaults to coronals, for example when he substitutes T for K, we realize that coronal sounds are a strength for him.
Exactly. Also, when we look at a substitution like F to B, which occurs here, and also gets documented down here under laryngeal features, we see that although Craig is replacing a voiceless fricative with a voiced stop, he is at least maintaining place. Note that nothing is documented here. So labials can be identified as a strength. We can use these strengths to address other needs, like using labial sounds in more complex word structures.
So it looks like we can discover many feature strengths, the maintenance of place for labials being one of them.
The lack of transformations of some features can also give us strengths. For example, I see that the place features for K changes from dorsal to coronal when K becomes T. Right here. But the transformation does not change the manner. And we don't see anything documented up here. So the continuancy of K, or lack thereof, remains the same when it changes to a T. Minus continuant can thus be verified yet again as a feature strength.